Right, you're welcome back again. At this point, we want to look at some statistical tests in past, but we want to, before we go into past here, we want to first confirm from how, because we want to start by looking at some tests statistically in a past environment, but we want to be very sure if the result we are getting from past is accurate. Want to at least confirm the authenticity of the result we get from past by comparing the result with our result. So I want to first show you this result before we go to past environment. We want to look at a single sample test first, all right, which means to compare the mean of a sample with a no reference. If there is there is no reference, we choose 0 as our mean, as our reference mean. All right. So let's say we want to use a data set containing the weight of 20 mice. We have already done this before in one of the my section that I posted. So let's say we want to create this now. We create this data set, right, which contain mice of 20 mice rather. So now, before you go further, I want to save I want to save the copy of this dataset in my folder so that I can use it also in past. So I click on save, so it's save. All right. So let's since the size is not large enough, let us check normality Shapiro test first. Shapiro test. Okay, let's just run Shapiro test. All right. We have 0.22. Just take note of those results we are getting so that we can compare later with past. We got a 0.22 for our Shapiro test, which passed the test, okay, for normality check. All right, so let's say we have a research question that says, is the average weight of the mice differs from 25 grams? So let's say we have the hypothesis that says the mean weight of the mice is 25 grams, and the alternative says the mean of the weight of the mice is not 25 grams. So we want to check. So we run the t-test here by passing our reference mean to 25, right? So we get the result. So let's see what we get. So our result, we have our t is minus 12.13. Our p-value is 2.15. Is over 10, is about minus 10. So we have lower bound of an upper bound, lower bound of 18.55, upper bound of 20.44, and we have our mean estimate to be 19.5. So there is a difference, all right? That's what it means. There's a difference. So because this value is significant, and we can even see the significant here. We can see the mean here. What we got is 19, not 25. So we are saying that the average mean of the mice is not 25 grams. It is 19.5. So which means we do not reject alternative hypothesis. Okay, so we do not reject it. So in favor of null. All right. So that is what we got now. So take note of this result now. Okay. Let's now say that okay, our reference mean is 0. We can do like this. All right. Or you can just clear like this. Two of them is correct. Okay. It assumes that the reference mean is 0. All right. So let's just leave it this way. Two of them is okay. So let's run this now again. So we are setting our reference to 0. So now when we set to 0, we have our t is 4.43.008, and the p-value is equal to 2.2 is for 16, which means the true mean is not equal to 0. That's what it means. Then we have a lower and upper bound, and we have 19.5. So this is also significant. All right. So what I'm saying here that the average mean is not 0 and not 25. All right. So we want to check if the result we get here is the same as we get in the past before we can continue with the test in past, so that we can ascertain that what we are getting from past is accurate, is confirmed. Okay. So let's go to past now. I've saved this. I've saved this data set. I've saved it here in past. So this is it. So I'm going to open it in Excel and go and copy it in past. All right. So this is it here. Okay, I open it from here in Excel. All right. So this is it. All right. So we don't need this. All right. So these are the names, and this is the weight of the mice. So copy this, copy, go to past. So as usual, now this time around we have a column, so you can paste it now, right? So just a paste, right? So because our ID of the mice wants to be here, okay? Even though we don't need it, so what we want to be here. Right? So we want to first check Shapiro first to confirm before we go into testing. So let's confirm if we pass the test. So we go to univariate normative check here. I click here. So Shapiro test says 0.224. Can you see 0.224? What do we get in R? Let's check again. This 0.224 for Shapiro test p value. In R, our Shapiro test in R shows that 0.224. Can you see? Our week is 0.938. Okay. So let me see here in past also 0.938. Can you see? So we should make it to be very accurate. Now let's go for testing now. Okay, the same test we perform. Let's perform now. Go to t-test. A single t-test in the past. So just run this here, run this line. So here we want to supply 25 first to see the result. All right, 25. It should be our MU now, our reference mean, our theoretical mean. So 25. So if you run this now, we compute here. So let's see what we got. We got our sample mean is 19.5. Lower band is 18.55. Upper band 20.44. Then this is difference, okay? Between minus, we will subtract 19.5 plus minus 25, we get 5.5. So our confidence interval is this. So our T is minus 12.13. Our P value is equal to 2.1583 E raised to power 10, which means are significantly different. So it's our accurate. So let's go to R and see the result if it's correct. What we got here. So don't forget, look at what we got here, and let's check R for 25. Okay, for 25. So this is 25 now. See what we got here in R. We got a minus T is for the minus 12.13. All right, and the P value is equal to 2.15E8, which we got here also in R. Can you see? I mean in past. Can you see? 25. Look at what we got here. T equal to minus 12.13 and P value equal to 2.158. See, we have the same thing here. All right. So when you now change, let's now change the reference mean to 0 now. Let's change to 0. Let's say we want to say, okay, our reference mean is 0. So we now compute again second time. So we can see we are getting we also get 19.5 again, and our lower band upper band does not change as such. And we have our T value now becomes 43.008, and our P is now 2.1257 E per 20. So which is significant. So let's check our R and compare. Don't forget we have 43.008 for T and P 2.1257 E. All right. So let's see for 0 now. For 0, our you can see T is equal to 43.008. Our P value is equal to what? 2.216, which is almost equal. So our mean C of difference is 19.5. So it's not equal to 0. That's what it's telling us. And we have upper band and lower band, upper bound equal. So this is telling you that whatever you get from past is authentic. Right? It's authentic. So you can count on past. That's what I'm trying to let you. So other tests follow the same approach. Okay. So now before we now go back to past now, and we now begin to compute some statistical analysis and some tests there as we proceed. So this is just to share to confirm that past is okay when you compare with other program in terms of a result that we get from past. So that is that for today, and this is the result we get for T test. Thank you so much. I will see us in the next class. Bye for now.